Hello, right, soldering principles, just basic soldering for electronics. The essential bits you need are a reasonable soldering iron, a clean tip, and solder and flux, as in flux cord wire, flux cord solder wire. Now, one thing is, don't bother with lead free. That's required for consumer electronics that are mass produced and they're going to end up in a tip or whatever, where lead would be a bad thing to get into groundwater and whatever. For DIY stuff and for a lot of other fields, including industrial and medical stuff, tin lead is perfect, and it's much easier to use, and it will give you a lot less hassle, and it'll just that alone may cure some problems if you're having difficulty with soldering. So you need a good iron and clean. A sponge, a cellulose sponge, as comes with lots of soldering sets, is ideal. Wet it with deionized water if at all possible, because over time, if you use normal tap water that contains minerals, the thing will go hard, like it'll set like a rock as the water keeps evaporating out of it and the minerals are left behind. If you use deionized water, it will last much longer. So give the tip a wipe and just touch it with a bit of solder, and that's tinned. I've got another camera here I'm trying to set up. The camera's bouncing a bit. Anyway, so that's a clean tip. You can see the flux burning off as it's used from the solder. Just put that away a bit. Now, the critical parts and the most important thing in how soldering actually works is that the joint itself, the parts you are soldering, are being heated. Then when flux is applied to the hot metal, it dissolves away any oxides and contaminants as far as possible, and the solder alloys into the metals. It's not glue. If you try and just transfer solder with the iron to an untinned item, it'll make a mess. It won't stick, because it's not, the metal itself is not hot. That's not alloyed in. All you've done is kind of put a glob on the surface which will break off. So that just does not work. So don't bother trying it. What does work is if you use the iron to heat. The iron should be tinned slightly, just slightly wet with solder. I'm hoping I'm getting this where you can see it in the other camera. The metal you're soldering gets hot. Then, as you apply solder, the heat from the metal being soldered melts it and allows the flux to be deposited directly into the joint. So you get a nice smooth joint. You can see that's got nice smooth edges here where the solder's flowed along the metal. If I put a component in, I'm not going to go crazy, I just don't want to waste parts, but just put something, I'll put it in on a separate part of the board away from the existing ones. So I was going to solder that. You can trim it before or after. If you bend the lead slightly so things don't drop out, it can be neater to solder after trimming. So I'll trim the wires on that, make sure I've got that bit there in the field of the camera. So I'm trying to look over the back of the lens, I can't even see what I'm doing from here. Can't see, oh there, right, gotcha, right. So everything's bounced out. I've got the 3 cameras and a light all on different stands, and everything's a bit bouncy. So apologies for any jitter. So iron on the joint against the component lead, then apply solder to the joint area. Give it time to just flow through. and you should get a nice clean joint. I mean, this bit of strip board is it's probably a decade or more old, so it's not flowing particularly brilliantly, but it is working, as you can see. Just do another put a resistor in there. Same thing again. I'll do this one. I'm looking at the other camera still, trying to figure out what's where. I can't find the I can't find the leads in the other camera. The close-up one. There. Sorry about that. Oh, I see one lead's pointing straight at the camera lens. That's why I can't see it. I'm looking at end on. So the same thing again. Try and make sure it's visible. Heat the joint. Apply solder to the parts being joined, and it should flow out nicely. Now that's the commonest technique for fitting components to a circuit board or soldering general joints. There are other techniques quite commonly used and which are very useful, and one of those is reflowing. I mean, for fitting wire to board, to a circuit board, you can just put the wire through and then solder the joint normally, as I've been doing with the other wires. I'll find that one. And again, you could trim it before or after, and that's a joint. The other technique I was mentioning, reflowing, which can be useful in certain circumstances, is tin the two parts you're going to connect. So tin the wire. Where is it? So that's the wire. We tin the wire first. Oops. Trying to get in the solder rather than a bit of insulated wire. Tin the wire first. Regularly keep your iron clean. Tin the other part that's going to be connected to it. Now, because they're both flowed with solder, they don't need any extra flux or solder. So you just heat the two together. And I missed it. The camera in. Try again. Keep forgetting how small a field of view that camera's got. Right. Right. So just tin the other part it's going to solder to. Just say that bit there. I'm going to move it out of view. At the other part that's already tinned, put it in position and reheat. So you're reflowing the existing solder. Because everything's already properly tinned, you don't need any extra solder or flux. You still get a very nice joint, and it's perfectly acceptable. So that's the basic principle for normal electronics. I mean, there's a lot of other techniques for different materials. I mean, you can use solder paste for surface mount and a heat gun, and that needs to be the solder paste with flux in it for initial joints, as the metals need the flux whilst they're being heated. And if you're not applying it from a fluxed wire, then it needs to be in the paste. Or if something's already been reflowed, tinned on one side but not the other, then it needs flux on the side that's not just been tinned and already got a good proper flow of solder on the joint. So if I was going to, I mean, it's not something you'd normally do with an iron, but if I was going to solder a bit of wire onto here, I'd tin the wire but not here, and I was going to do it with a heat gun or whatever, a blow lamp, then you have to flux things. Same as plumbing, where you're using a blow lamp to heat, then you need to flux the joint and apply solder as well, separately. And it's a lot of metal work as well, general metal work, joining pieces of brass. Anything that's too big to use with an iron, you'd need to use flux and separate solder, because trying to apply, or for large joints, trying to apply bar solder or whatever in a blow lamp flame doesn't work very well. So you've got to alternate between applying the heat and the solder. So it needs the flux already in place for when you heat it to clean the metal. Anyway, I'm waffling. So anyway, I hope that was interesting and a bit of use. Thanks for watching.